Hello, my name is Jeff Diadolfi, and this is my project for Microsoft Imagine Cup. And what I made was an epilepsy checker, and what this does, it allows you to copy and paste the URL of a YouTube video to see if there are any fast flashing lights or anything of that nature, which might be a problem for people with epilepsy. And I have these two examples. One is a slow color change, and the other is a fast color change. And I'm not actually going to play this one, but what you can do is just copy the link and paste it. And this only allows for subclips of up to 10 seconds. And just to demonstrate, this is a low risk video that I just entered into the URL. And what this does, it gives you the total frames of that subclip, the frames per second, and as you can see with this slow color change, there are no flashes. These are flashes per second. But if I go back and I put in the high risk video, you'll be able to see that this one picks up on the fast flashing. Yeah, so this one is a high risk because there are multiple flashes per second, and during my research I saw that at least five flashes per second could start to pose a risk, and anything above that is definitely high risk. So going back to the code, so looking at the code, this is the code for the algorithm, and one challenge that I did face was that running this locally, everything works fine, but I hosted my app on Heroku, and when it's hosted on a live website, it is a bit buggy. As of right now, as of recording this on January 20th, it's a bit buggy, but that's still under construction. But going through this code, the main meat of the code is this analyze function and this compare frames function. And what I'm doing is really just going through, iterating through each frame of the YouTube clip using OpenCV, which is a computer vision library for not just Python, but multiple languages. But I just compare the frames using like sort of a heap data structure. And what I do is I just calculate the mean color values of each frame. So the mean R channel, mean green channel, and mean blue channel. And I just compare them from the previous frame. And if there's a drastic difference, I mark that down as a flash, but I don't actually put that flash into the flashes per second array unless it has a pretty big difference in color. And then I iterate through that to see how many flashes we get per second, so that way we can determine if there's too many flashes in just 1 second.